Current project, gravity-assisted pulse motor update. We've measured the stator resistance from leg to leg at the center tap star configuration, and we're getting about 30 ohms internal state. The stator resistance. The wire that's wrapped around all the poles, I guess. We'll attach a 12-volt load and see what
kind
of results.
We're using 12-volt landscaping lights as a load.
There's just the one garage door spring on the other end. No weight on this end, and as we, engage the spring, basically at 12 volts, the 12-volt load, there's such a high I squared R loss at the stator that the system hardly even moves. So now we'll try it with a 120 volt load, and we'll see what kind of results we get. 50 watt 120 volt light bulb, flood lamp hooked up, and we'll try the same test. Now you can see it illuminates. It requires a little more manual assist. There it goes. Just to give you some idea, the force required the light, to even illuminate the light, it's quite substantial. We can reduce the gear train to a 3-to-1 or a 1-to-3. That'll help. The other important thing is the DC to DC step-down converter will greatly reduce the I squared R loss at the stator, where most of the load is actually coming from. And so at 12 volts, 50 watts, you require about, real rough calculations, approximately 500 watts at the output shaft to illuminate a 12 volt, 50 watt load. So that's approximately 10 times the force required. It's just to get some idea of the forces we're dealing with, approximate numbers, to get an idea of how much actual weight will have to be suspended or attached to the rack and pinion. Thanks for watching. Enjoy the day. More tests to come. We'll be working on the DC to DC step-down converter, and see if I can reproduce my results from a couple years ago. Thanks for watching. Enjoy the day.